An emerald light races past Mars. But what exactly is it? A comet, a fragment of another world, or something we don't yet understand? Just as interstellar traveler 3I Atlas makes its closest pass, Earth goes blind, NASA's data streams cut off, telescopes turn away to protect their optics. For 6 weeks, the planet's eyes are shut. Love, real cosmic mysteries told as they unfold. Subscribe now so you don't miss what Mars discovers next. While Earth drifts in darkness, Mars becomes the only place still watching. A handful of orbiters and rovers pivot their instruments toward the emerald glow, racing against time to capture what no one else can see, a visitor from beyond the stars. The countdown has begun, and the question we'll chase through this story is simple. What did Mars witness that Earth never could? It starts with a simple twist of geometry. On October 3rd, 2025, the Sun slides directly between Earth and the path of 3I Atlas, a comet from beyond our solar system. The angle between the two shrinks below 10 degrees. For astronomers, that's a death zone. One wrong move, and a billion-dollar telescope could burn out in seconds. By nightfall, observatories go dark. Screens dim. Tracking freezes. The countdown hits 0. For 6 long weeks, Earth's skies are sealed. The interstellar traveler blazes past the inner solar system unseen, its secrets buried behind the sun's blinding glare. Back on Earth, the world waits, blind. Mars becomes the only watchtower, but 225 million kilometers away, Mars sits in just the right position, offset enough to see what Earth cannot. From the red planet, the Sun-comet angle stretches wide open, more than 50 degrees of clear sky. And that's the answer to our first question. When Earth lost sight, Mars became our eyes. Every orbiter, every rover, every line of code turned toward the emerald light racing through the dark. Humanity wasn't blind after all, just watching from another world. Now another question takes its place. Could these machines capture something that changes how we see comets forever? Could these machines capture something that changes how we see comets forever? No one knows, but there's no time to hesitate. When the blackout begins, Mars orbiters are repurposed almost overnight. Instruments designed to study dust storms and thin air are suddenly aimed at deep space. Teams rewrite code in real time, swapping safety protocols for risk. The clock is merciless. Every orbit, every data relay, every second counts. Inside mission control rooms across 3 continents, engineers improvise. They rewrite pointing commands, reroute telemetry, and squeeze every byte of bandwidth they can. There's no bureaucracy now, no careful pacing, just a race against physics. If the geometry shifts, if the comet moves out of frame, the data is gone forever. Above the red planet, the machines respond. Cameras rotate, spectrometers lock on. A fleet built to study Mars now stares into the void. The fleet of observers, at the front line is ESA's Mars Express. Its high-resolution stereo camera and Omega spectrometer capturing multispectral images of 3I Atlas from visible to infrared. Alongside it, ExoMars Trace gas orbiter dissects the light into thousands of wavelengths, searching for rare gases or molecules no solar system comet has ever shown. The UAE's Hope orbiter, with its ultraviolet spectrometer, scans the bright emerald coma from a global orbit, while China's Tianwen-1 watches in near-infrared, gathering context images and spectra for cross-reference. Even NASA's Mars Reconnaissance Orbiter, constrained by the US government shutdown, keeps its instruments on standby, ready to target Atlas the moment clearance arrives. Farther out, ESA's JUICE spacecraft waits to catch a last glimpse from beyond Mars's orbit. Together, they form an impromptu network, a planetary collaboration held together by timing, trust, and a shared question whispered through deep space. What will Mars see first? Perseverance's 9-minute streak. It begins with a streak. 9 minutes of stillness over Jezero crater. The Perseverance rover's cameras locked on the Martian sky. Frame by frame, stars trail across the blackness. Then one line cuts differently, fast, straight, deliberate. At first, it looks like a glitch. A cosmic ray hit, maybe. But when image processors back on Earth stack the frames, the line doesn't disappear. It holds steady, faint, but consistent across every exposure. The calibration team runs the checklist: flat fielding, dark subtraction, pixel corrections. Still there. Next comes astrometry. They pull data from NASA's SPICE toolkit, aligning the rover's gaze with the sky's coordinates. The line's position matches perfectly with the predicted path of 3i Atlas, moving at nearly 60 kilometers per second. Coincidence? Maybe. But the flux readings tell a different story. The light curve is smooth, no spikes or flares, exactly what a diffuse, fast-moving coma should produce. False positives drop away one by one until only one conclusion remains. Perseverance has just recorded an interstellar comet streaking across another planet's sky. For the first time in history, humanity has seen an object from another star, not from Earth, but from Mars. The last Earth-based portrait. Just days earlier, on September 25th, one final image was captured from Earth. A small observatory in Namibia caught a fading emerald glow, the last clear portrait before the blackout. In the frame, the coma stretches almost 700,000 kilometers across, twice the distance from Earth to the Moon. But the structure is strange. Instead of a trailing dust tail, 3i Atlas shows a wedge of material pointing toward the sun, an anti-tail sculpted by slow, heavy grains. Around it, ripple faint arcs and layers, as if the comet were shedding shells and pulses, not streams. These images, one from Mars, one from Earth, tell the same story. This isn't a normal comet. It's something colder, larger, far more deliberate in its behavior. The numbers are the first clue that something about 3i Atlas doesn't fit. Most long-period comets limp into the solar system at 20 or 30 kilometers per second. Atlas doesn't limp, it roars, cutting past Mars at nearly 60. By the time it rounds the sun, models project it will spike past 68 kilometers per second, fast enough to leave the solar system forever. Its orbit is just as strange. Instead of diving in from a steep, random angle like most interstellar visitors, Atlas slides almost perfectly along the ecliptic, the same plane as the planets. Statistically, that's nearly impossible, like throwing a dart from another star and hitting the solar system's bullseye. Scale and structure brightness estimates paired with coma models suggest a nucleus at least 5 kilometers wide, one of the largest interstellar bodies ever observed. But its surrounding cloud, the coma, is even stranger. Instead of a filament tail streaming away from the sun, Atlas carries a layered shell-like envelope, stable and symmetrical. Polarimetry shows each layer reflecting light differently, as if the material were organized, not scattered. Even as it endures solar heating, the structure barely changes. No violent jets, no sudden bursts, just a slow, steady drift. For a comet, that's unnatural composure, almost mechanical. The CME test, then comes the solar storm. On September 25th, a coronal mass ejection slams through the inner solar system, a blast of plasma strong enough to rip ions from most comets in hours. But when it hits 3i Atlas, nothing. No flare, no new tail. The coma holds its shape, unmoved. For plasma physicists, it's baffling. A body made of ice and dust shouldn't survive a storm like that untouched. Is the coma shielded by chemistry we don't understand? Or by something else entirely? The math works. The physics mostly holds. But the behavior, the restraint, doesn't. So, what did Mars see first? Not chaos, not fireworks, but something quieter and stranger. As the first packets of data streamed back to Earth, analysts expected turbulence, a flaring coma, fragments breaking away, a tail twisting under solar wind. Instead, the images showed stillness. The green halo remained crisp and symmetrical, every layer holding its shape. No debris clouds, no outbursts, just a calm, steady pulse, almost as if the object were controlling its own shedding. That was the first revelation. While every known comet dances wildly near the sun, 3i Atlas moved with purpose, a true interstellar origin. One thing, however, isn't in doubt: its origin. The orbit is hyperbolic, mathematically unbound to the sun. Once it passes perihelion, it will never return. Atlas joins a tiny club of visitors from beyond. Oumuamua in 2017, Borisov in 2019, and now this. But even among those, Atlas stands apart. Larger than Borisov, faster than Oumuamua, and far more stable than either. It's a paradox. A comet that acts nothing like a comet. Scientists agree on one fact: it isn't from here. Everything else is a debate. Is 3i Atlas simply a cosmic outlier, a relic of alien chemistry frozen in time? Or, as some quietly wonder, is its precision the signature of something built, not born? The data says natural. The behavior says maybe not. And so, the story doesn't end with what Mars saw, but with what it couldn't explain. The moment the first images of 3i Atlas reached Earth, everything changed. Within hours, raw data from Mars Express, TGO, and HOPE began appearing in public archives. For the first time, an interstellar event wasn't hidden behind closed research doors. It was open source. Anyone, anywhere, could download the files, study the spectra, and see the mystery for themselves. Citizen scientists jumped in first. From backyard observatories to amateur forums, people compared Mars-side data with their own pre-blackout images. They plotted motion fits, tracked brightness curves, and debated the meaning of the anti-tail. In Arizona, a group of students used open telemetry to recreate the Perseverance sighting in 3D. In Japan, a hobbyist astrophotographer noticed subtle ripples in the coma's symmetry that even professionals had missed. The agencies watched and adapted. NASA, ESA, and the UAE began mirroring one another's databases, removing embargoes that once delayed discoveries for months. Redundancy became policy. Transparency became protection. In a universe that offers so few second chances, the lesson was clear. When something from another star comes knocking, the whole world needs to look. October 3rd, 2025. For 6 tense hours, Mars became humanity's only eye. Orbiters tracked every flicker of emerald light. Rovers caught faint streaks across the sky, and data streamed home across millions of kilometers. When the transmissions were finally pieced together, one truth stood out. 3i Atlas is unlike anything we've ever seen. Its emerald glow stretched over 700,000 kilometers, vast, layered, and eerily stable. The anti-tail still pointed toward the sun. The coma's symmetry refused to break. Even after the solar storm, no ion tail, no violent flare, just composure. Calm where there should have been chaos. Scientists can explain parts of it. The chemistry, the velocity, the physics of an object forged in another system, but not all. Some questions still hang in the silence between planets. Why does it move with such precision? Why did it resist the sun's fury? And if 3i Atlas isn't a comet as we know them, then what is it? For now, the answers drift with the object itself, out into the dark, away from Mars, away from us. But its legacy remains. Proof that when Earth goes blind, Mars can still see, and so can we, if we choose him to look. If you followed this far into the unknown, don't forget to like, share, and subscribe, because the next visitor from beyond the stars might already be on its way.